In this video, we're going to be talking about the discriminant. So the discriminant is b squared minus 4ac, and that is basically what's underneath the radical in our quadratic formula. And depending on what our b squared minus 4ac equals, it tells us how many and type of solutions a quadratic function has. So here in that blank it says use to determine how many solutions, and I'm going to make a note and type a quadratic function has. So there's basically going to be three different cases. If our discriminant b squared minus 4ac is positive, or in other words, greater than 0, then there's two real solutions. So in other words, this is positive. And a graphical example of what that would look like is a parabola that crosses the x-axis in two places. So I'd have two real solutions here and here. If our discriminant is equal to 0, then there is one real solution. And we see in our example here, the parabola touches the x-axis in exactly 1 point. And then we have that if the discriminant is less than 0, in other words, if it's negative, then we're going to have two imaginary solutions. And if we're graphing that, we see our parabola does not cross the x-axis at all. So let's go through some examples of analyzing discriminant. So here, directions, we're going to find the discriminant of the quadratic equation and describe the number and type of solutions of the equation. And so here, remember that our discriminant is equal to b squared minus 4ac. So looking at number 1, I have x squared minus 6x plus 10 equals 0. I'm going to first label my a, b, and c. Here I see that my a is the number in front of x squared, which is 1. B is the number in front of x, which is negative 6, and c is 10. So filling in b squared minus 4ac. Plugging in my values, I get that b squared is negative 6 squared minus 4 times a, which is 1, times c, which is 10. Negative 6 squared, I get a positive 36 minus 4 times 1 times 10, which is 40. And 36 minus 40, I get negative 4. So my discriminant here is negative 4. And now since negative 4 is less than 0, in other words, negative, we see in our chart right here that this is going to have two imaginary solutions. Okay, let's look at number 2. Number 2, I have 5x squared plus 10x plus 5 equals 0. I'm going to first label my a, b, and c. My a is the number in front of x squared, which is 5. B is number in front of x, which is 10. And c is the last number, which is 5. So filling in b squared minus 4ac is going to equal to 10 squared minus 4 times a, which is 5, times c, which is 5. 10 squared, I get 100, minus 4 times 5 is 20. 20 times 5 is 100. And 100 minus 100, I get 0. So my discriminant here is 0. And we see in our chart above that when our discriminant is equal to 0, this is going to be one real solution. Okay, let's look at one last one. Here I have 2x squared minus 9x plus 8 is equal to 0. So first labeling my a, b, and c, I have a is 2, b is negative 9, and c is 8. So filling in my formula, I get negative 9 squared minus 4 times 2 times 8. Negative 9 squared, I get 81, minus 4 times 2 is 8. 8 times 8 is 64. And 81 minus 64, I get 17 as my discriminant. Now, since 17 is greater than 0, by my chart above, I see that this is going to have 2 real solutions. So in other words, if I were to use the quadratic formula to solve all 3 of these problems, for the first one, I would have the imaginary number in the front. So I would have that I that will be in my answer. For number 2, I would only get 1 answer. And then for number 3, I would get 2 real solutions. So there wouldn't be an I in my solution.